In the course of 30 years, space development has ceased to be an ideological luxury and has become a strategic and economic necessity. Today, even poor countries have to take space technology into consideration when planning their development strategies. Tomorrow's space powers are already emerging among countries that are considered to belong to the third world. China and India already have many achievements to their credit, and Brazil is rapidly becoming the leader in space technology in South America. With more than 1 billion inhabitants, China is destined to become one of the giants of the 21st century. An heir to an ancient tradition and a modern Marxist revolution, Chinese society will face many challenges between now and the turn of the century. China seems to attach a great deal of importance to space technology as an instrument for its development. Whether it be telecommunications, remote sensing of natural resources, or strictly military and strategic priorities, modern China is counting on the space technology which it has to develop and master. As early as 1960, the Chinese were launching rockets toward the upper atmosphere. They even placed dogs aboard to study the biological repercussions of such excursions. Ten years later, they sent their first satellite into orbit. Since then, they've continued to develop their own space technology. Chinese leaders are aware they can't accomplish everything overnight. As China is developing its own technology, it also uses the technology developed by other countries. The Chinese have just signed an agreement with the United States, which will allow them to receive and use pictures taken of China by Landsat satellites. They plan to use these photographs in agriculture, geology, environment, and land management. This kind of international cooperation has not prevented China from developing its own space technology. As in many other countries, the Chinese invested in space technology primarily for military reasons. The Chinese civil space program exploited the knowledge gained by developing ballistic missiles. This program was always conducted under the auspices of the Popular Liberation Army, even though it was coordinated by the Ministry of Astronautics. This ministry received generous support from the Chinese government. It regarded the program as a way of attracting technology and foreign capital, which the country badly needed. China now has 3 bases for heavy launchers, whereas the USSR and the United States have only 2. Another site has recently been constructed southwest of Beijing. This new base, its exact location still secret, will be used to test intercontinental missiles. The site was also designed for launching along the north-south axis and will quite likely be the departure point for remote sensing, meteorological, and spy satellites. The other two bases are located in Jiuquan, in the Gobi Desert, and Xichang, near the Burmese border. The Jiuquan base is used primarily for launching satellites into low orbits. The Chinese launch their recoverable reconnaissance and remote sensing satellites from Jiuquan. These satellites stay in space for only several days, and the films are recovered once the satellites have returned to Earth. The Chinese have already launched about a dozen of these recoverable satellites and are offering this service on the international market. This type of mission is well suited to developing new materials and the study of biological phenomena in space. These commercial satellites were sent into orbit by Chinese rockets known as Long March 2. These two-stage rockets can send payloads weighing more than 2 tons into low orbit. The same rocket can also be equipped with a third stage, enabling it to place payloads of slightly more than a ton in geostationary orbit. It's called the Long March 3. Its third stage engine uses liquid hydrogen and is at the cutting edge of international rocket technology. In the first attempt to launch a satellite, the third stage engine of the Long March 3 failed to ignite. In April of 1984, however, the rocket successfully launched the first Chinese telecommunications satellite into orbit. Another similar satellite was launched in February of 1986. The lifespan of these two satellites will soon be over, and a third geostationary satellite will be launched. Until they establish their own satellite telecommunications network, the Chinese have rented 4 channels on international Intelsat satellites. They transmit television, telephone, telegraph communications, and computerized data on these channels. More than 2,000 land-based receiving stations are scattered throughout China. In the early 90s, the Chinese are planning to launch a television satellite which will broadcast educational television to different regions across the country. This satellite will be sent into orbit by one of the Long March 3 rockets. These launchers function well and are expected to be used for 3 missions in 1988. Curiously enough, 2 missions were requested by an American company which wants to relaunch 2 satellites that had been lost and later recovered by the American shuttle in 1984. Different generations of Long March rockets have launched approximately 20 satellites. Even though China presently carries out 2 or 3 missions a year, the Chinese authorities claim they are capable of building and launching 10 rockets a year. The Chinese have initiated a very aggressive marketing program. They have established offices all around the world and their prices are considerably lower than those offered by the Europeans or Americans. For missions which have to be launched near the equator, rockets take off from the Space Center in Xichang. This base is used only to launch geostationary satellites. That's why it's near the equator. The various components of the launchers are brought to Xichang as separate pieces. The control rooms and flight monitoring systems are relatively modern. A second launching pad is under construction. The launching facilities in Xichang will be able to accommodate the Long March 4 rockets, which will be operational in 1989. These launchers will use 4 liquid propellant rocket boosters and will be able to launch payloads weighing several tons. In the long run, the Chinese plan to use this new generation of rockets for manned flights and to launch their own space station. Like China, India has increasingly regarded space as a way of solving its practical development problems. Despite its limited resources, India spent more than $300 million a year on a space program which it hopes will give it independence in space. India's space research organization, ISRO, employs more than 10,000 people. Another 5,000 work for the Indian Ministry of Space. The Indian government has showed an interest in space technology for more than a quarter of a century. Since 1963, the Indians have launched more than 1,000 meteorological probes from their launching pads in Tumba and Sriharikota. Some of these solid propellant rockets have reached altitudes of more than 100 kilometers.
8, 7, 6, 5, 4, 3, 2, 1.
It was, however, a Soviet rocket that in April of 1975 launched the first satellite built in India. The Aryabhata, an experimental satellite weighing 360 kilograms, was built in its entirety at the research center in Bangalore. Its sole mission was to observe the Earth. 2 more sophisticated remote sensing satellites were also built by ISRO and launched by Soviet rockets. Bhaskara 1 and 2 were launched in 1979 and 1981 to study India's weather and survey its waters. In July 1980, after one failed attempt, India sent up its first satellite on a launcher designed and manufactured in India. The SLV-3 rocket propelled a small experimental satellite into space. The Rohini 1 weighed only 35 kilograms. On April 17, 1983, an improved version of the SLV-3 successfully launched a new Rohini satellite capable of relaying pictures and other information about the Earth's surface.
8 minutes and counting. Radar 2 is in channel 1. EM1 in channel 1.
CDC1 in channel 1.
CDC2 in channel 1. Minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
A new version of the same rocket, the ASLV, is currently under development. It will be able to launch a payload of 150 kilograms into orbit. Unfortunately, the first flight of this launcher in March 1987 ended in failure, and a new generation Rohini satellite was lost. 3 other missions have been scheduled for this rocket. Over the long run, the ISRO will develop the PSLV, a launcher capable of sending a 1-ton payload into polar orbit and a 2-ton payload into geostationary orbit. This rocket should be in operation by the end of the 80s. It'll be India's first truly world-class satellite. A new launching base will also be built for this rocket for polar launchings. It will, however, be a number of years before India can launch its own astronauts. On April 3, 1984, the first Indian astronaut was sent into space in a Soviet space capsule. During the 8-day mission, Rakesh Sharma carried out several scientific experiments. He also performed yoga exercises while scientific instruments recorded what was happening to his body.
И это мы, я сделаю на борту завтра. И с результатами этого эксперимента мы сравниваем с членами экипажами Юра и Гена. И после возвращения с Земли посмотрим.
Even though they don't have their own launchers, Indian researchers are interested in the applications of space technology. Between 1975 and 1979, they experimented with the American ATS-6 satellite and the French-German Symphonie satellite. During these experiments, television programs were broadcast to more than 2,400 villages equipped with small satellite dishes. With a population approaching 1 billion and with more than 500,000 villages, India is planning to use satellites to set up a comprehensive national communication and educational infrastructure. The first real Indian telephone system was made possible by a geostationary satellite. In June 1981, an Apple telecommunications satellite was launched by an Ariane rocket. Besides designing and building the satellite, Indian experts controlled its journey into space. As a result, they acquired enough expertise to be able to run their own satellites one day. The INSAT-1A satellite, also designed by the ISRO, was the first satellite in the world to combine telecommunications and meteorological functions. Made to measure for India, this satellite was built by Ford Aerospace and was launched by an American Delta rocket from Cape Canaveral in April of 1982. Unfortunately, the satellite stopped working several months later, causing a great deal of resentment against the Americans. Another similar satellite was launched without mishap by the shuttle Challenger in August of 1983. It functioned as expected. A third satellite was to be launched in September of 1986, but the launching had to be postponed because of the Challenger tragedy. The first INSAT satellites enabled Indian television networks to broadcast in 15 different languages and to expand their service to 60% of the country. A second generation of INSAT satellites should be launched by an Indian PSLV launcher sometime in the 90s. This new series of satellites will offer combined telecommunications, television, and meteorological services. To solve its own meteorological and telecommunications problems, Brazil, like India, has embarked on its own space program. Brazil's first undertaking was to develop probes. Since 1964, several hundred of them have been launched from the base in Alcantara. A family of 4 different models, the most powerful can launch a 1-ton payload to an altitude of 600 kilometers. The main purpose of the probes is to better understand the atmospheric environment around the equator and over the Amazon. Brazil now has its own system of telecommunications satellites. Manufactured by Spar Aerospace of Montreal, the Brasilsat 1 and 2 satellites were launched by Ariane rockets in 1985 and 1986. These satellites are owned by Brazil's national telecommunications company, Embratel, which also owns more than 20 ground-based stations in different regions across the country. Brazil is still the only country in South America to have its own comprehensive space program. It provides for the building of 4 satellites, the development of a launcher, and the establishment of a launching pad completely equipped for the control and monitoring of satellites. It's an ambitious program and requires investment of more than $1.5 billion over a 15-year period. The Brazilians have one launching site in Natal. A new launching pad is currently under construction near the city of Alcantara. The Brazilians will launch their next launcher from Alcantara. This rocket will be composed of 4 solid propellant stages and will be capable of launching a payload of 150 kilograms into low orbit. Brazilian experts estimate it will be used in 1989 to launch a series of satellites designed to study the environment and for the remote sensing of natural resources. As with China and India, Brazil intends to develop its space expertise according to the country's own requirements. The example provided by these three countries proves that even if the sufficient means to develop a coherent and independent program do not exist, third world countries must take space technology into consideration when planning their development strategies.